Bismillahirrahmanirrahim. This is our second lecture on automatic assembly, and today actually on this lecture we are going to talk about feeders, generally as all feeding devices which used in automatic assembly. As I said, there are many feeding devices used in automatic assembly, and you can find them in being collected on the Institution of Production Engineer book. But in this lecture, I'm going to talk first about the mechanisms of vibratory ball feeder. Then we are going to talk about linear feeders. Then about different types of feeders, inshallah. Let us start our lecture, and we are going to talk about factors affecting the ball feeder speed. We talked about this in the last lecture, but let us say them again. Those factors are the effect of frequency and amplitude, the effect of track acceleration, the effect of vibration angle, and the effect of track angle, the effect of coefficient of friction. Those are the 5 effects on ball feeder speed, and we have talked about them in the last lecture. You can go back and see more about them. Now, I want to talk about something new, which is called the natural resting aspects of parts. The geometry of part shows the number of faces which the part can rest on. Say for a disc, say a piece of coin, I've got a piece of coin has only 2 faces, and it can rest on those 2 faces. But for a cube, it got 6 faces, and it can rest on any of the 6 faces. So, in the if I'm say want to orientate a disc, that will give me 50% each face. But if I want to orientate a cube, that means 10/6 each face. Actually, the first people whom did work on this area are Bradford and Bothroyd, and they got something which called natural resting aspects, which will show the percentage of efficient of feeding the part. And it is very important for us to know the efficient of feeding the part, because if the feeder say speed is 25 millimeter per second, that means if it is 100% efficient, it will give us the length of 25 millimeter. But it is 50% efficiency, it will give us 12.5 millimeter per second. And if it is 25% efficiency, it will give us 6.25 millimeter per second, and that will affect the number of parts which can be fed by the feeder, right? Part geometry affects the efficiency of its orientation. Bradford and the research work investigates this area. Also, Bothroyd based his work on design of assembly on natural resting aspects of parts. The efficiency of orientation affects the economics of automatic assembly. Definitely, the economics, if the feeder is very efficient, that means it is going to give us more parts. If it is low efficiency, that means it is going to give us less parts. This area will be discussed in details in the coming lectures. Actually, I'm not going to discuss it in details. Definitely, maybe if we got a tutorial, I'm going to discuss it in the tutorial. For example, the cylinder is classified to disc short cylinder and long cylinder. This is an example of cylinder. Cylinder can be divided into discs short cylinder and long cylinder. In the late work, Munch and Bosroyd classifies the cylinder as shown below. Actually, this is the first work by Munch and Bosroyd, and he tried to divide cylinder on 8 numbers, where he relate the diameter to the width of cylinder. Example of natural resting aspect of a short cylinder. Here is a short cylinder, and we find it can rest it on 4 sides. If you look at A, at the top up, B at one side, C at the other side, B1 at one side, where the closed part to the left and then the closed part to the right, and C is on the other side. And that means in a short cylinder you can get those 4 orientations on the feeder track. If we go down and talk about other vibratory feeding devices, then we'll talk about the feeder track later, inshallah. This is actually what's called linear vibratory feeder, which has been designed by Salford University. And instead of having a round track around the ball, the track now is linear. And this will ease the design and cutting of track, where the track can be cut on a CNC machine. Even in Salford, they developed a software which you can put in the CNC machine and cut the track directly from the geometry of the part. Here is the feeder working. Another design of the same feeder. As you see, the track now looks like what? This was called flat belt feeder, and usually it's used for longer part, and the belt got around motion, and it will feed the oriented part to the side of the feeder in the direction required. This is what's called a spiral elevator, where the part will elevate from a hopper to the helical track, and it's got the same configuration of the vibratory valve feeder, but the part will climb all this helix, and that will give a lot of orientation for the part. Here again, also called balance vibratory feeder, where the part will go round, not like the vibratory linear feeder. The vibratory linear feeder, the parts will fall down on a box, then a belt will move the parts up. Here, the parts will rotate on the feeder track, where it got two tracks which vibrate on opposite sides, and it is the same orientation or the same configuration, but here it got two vibratory tracks. Orientation of parts using vibratory feeding devices in automatic assembly machines. In automatic assembly machine, the part must be correctly oriented when they are fed to the workhead. Definitely yes. The device is employed to ensure that fall into 2 groups: those that are incorporated in the part feeder, which are usually referred to as in-pole tooling, and that with those that are fitting to the chute between the feeder and the workhead, called out-pole tooling. In other words, the orientation can happen inside the feeder track or in the chute out of the track, and which is in the track of the pole feeder or the vibrator feeder is called in-pole tooling, and which come out of the pole feeder is called out of pole tooling. The device is used for in-pole tooling, working on a principle of orientating by rejection. In other words, the natural resting aspect on the orientation which is required is only kept, and the other orientations will be rejected. And that means if it is 50%, say, that will reject 50% of the parts which come on the wrong orientation. If it is 25% efficiency, that means it's going to reject 75% of the parts which come on the other orientation which are not required, and keep only orientation which is required. With this type of devices, only those parts that by chance are fed correctly oriented pass through the device, while the other parts fall back into the ball. And actually this the way it works as a rejecting device which will reject all parts got being on the unrequired orientation. In some cases, devices are fitted that can be reorient the part. This is called active orientating devices, and they have the advantage that no reduction in feed rate occurs as a result of the rejection of parts. If we say that a feeder which can feed 25 millimeter per second and is going to reject 80% of the part and only 20% of the part will go, that means is going to feed 10 millimeter per second. But if that is not acceptable for the work head, and we want to improve this percentage of acceptance, we put a device on the feeder which will reorient some of those orientations or natural aspects of the part on orientation which is acceptable, and the pass will go, and this will actually improve the economics of the feeder. Some orientation track design, actually this is a design for a port. As you see, port can come on different orientation. First, he put a wiper, and the wiper will reject any port which head is up. Then he put a pressure brake, which also will reject any port which the head come first. Then after that, the part will fall on a slot, and now parts are oriented. You find most of, actually, I've got one of my students who identified 32 devices for orientation of tracks. And actually, those now 3 of them: a wiper, pressure brake, and a slot. Here, another way where he used a leg track. He used 2 devices actually here. Narrow. He inclined the track, and he used a leg track to stop washers from falling down. Here he used the scallop. This is another device where if the part come and head up, it will tangle on the scallop and fell down. Here he used another thing which is a V cut out. In this he used a rail, and the rail will make the part climb. At the same time he used a wiper, two different types of wiper to keep the part on the rail. Now in this he narrows the track so as the part come on the its longitudinal the part come on its longitudinal orientation will go, and the bus will by its side it will fall down. Here he used wiper and a wall projection and a narrow track. Here again he used he narrows the track, wiper and a rail. Here he used even a step. The step, of course, is an active device which will change the orientation of the part. When the part goes through the step, it will go upside down. Example of reorientation devices. So actual other devices. Just look at them and you find now this one, the part will go down on one side and the heavy head will go down, and this will reorient the part. Here the same, the part will hit the pin and the heavy part will go down first. Here reciprocating tube hopper, which makes the part go down on a chute. Here center port hopper feeder, where a plate move up and down, reorientating the part, and the part then go through a chute. Is the same as the previous one, but it's got a fork where the fork will collect pass and then pass go through chute. You see now here you use rotary mechanisms and so on, which is called external gate. And there are many devices which you can go down one by one and see them and study them. Right? I'm not going to go through all of them. Here you use a magnet. Here you use a kind of magnetic belt. And actually this is the end of our lecture. And the next lecture we are going to talk about feed track, escapement, part placement, mechanisms, and robots. In other words, now I finished talking about feeders, and we are going to next time to talk about other devices on the automatic assembly machine. Thank you very much for your attention. If you got any queries or questions, you can contact me at any time on my email or through my phone. Thank you very much for your attention, and please go back and read on the books which I provided for you. Thank you.